Dear students, in this class I am going to talk about the second part of the fifth unit, that is programmable logic devices. In short, we can call them as PLDs. Anyway, in the previous class I have explained the memory, that is nothing but first part of the fifth unit. That first part of the fifth unit heading is Semiconductor Memories. In the semiconductor memories, we have studied some broad classifications of the memory, such as ROM and RAM, and after that we have studied the static and dynamic RAM and the various types of ROMs we have discussed. So anyway, in this class we have to study the another part of this fifth unit, that is called programmable logic devices. As a name suggests, it is a programmable devices. Programmable means according to the given instructions by the programmer, these devices is going to make the function. Programmable means it can accept the changes. It can accept the changes in the instructions, and based on the instructions it can perform the function. After it performs a function, that program we can erase that one, such that we can write the new program to get the new function from the same device. So that the programmable logic devices plays the very important role in the digital systems, because the one programmable logic device is capable of implementing the many digital functions. So that programmable devices we are going to discuss now. Now I am going with the programmable devices. This is the actual programmable logic devices. We can have the various types of programmable logic devices. And from the classification of the programmable logic devices, in short we can call them as PLD. They can be two types. One is factory programmable devices, and the another one is a field programmable devices. In factory programmable devices, so we can have the two more types. One is read-only memory, another one is mask programmable gate array. So whenever we are studying the word mask means it can't be erased, that is having the fixed connections. So now here we are having the another type of the memories, that is nothing but read-only memory. It is a programmable device. According to the user program, this memory device is going to store the data. In case of read-only memory, we can see the two devices. One is a decoder, another one is a R plane. So anyway, that RAM we have discussed in the first part of the fourth unit, that is programmable read-only memory, we have discussed in that. So this RAM is a memory device, and it is a programmable one, so that we can call it as a PROM also sometime. PROM stands for programmable read-only memory, and the another type in the factory programmable device, that is a mask programmable gate array. And the next one is we can have the three types of field programmable devices also, which comes under the programmable logic devices. First one is SPLD, simple programmable logic device. Simple programmable logic device. So which includes the four again, which is PROM, just now I have explained. Another one is about the PLA, that is programmable logic array, and the next one is a PAL, that is programmable array logic, and the next one is a generic gate array. So all these four comes under simple programmable logic devices. In short, we can call them as CPLD. So in short, we can call them as SPLD. Then next category is about the CPLD, that is a complex programmable logic devices, and the next one is a field programmable gate array, that is FPGA. So it is a generally we can find this FPGA in the laboratories, electronics laboratory or the VLSI circuits laboratory, to implement the very big Boolean functions that may be some product and the product of some. We can make use this kit that is called as FPGA kit. FPGA stands for field programmable gate array. So this is about the classification of all the programmable logic devices. In short, we can call them as PLD. PLD stands for programmable logic devices, which can be programmed and which can make the function according to the program. Program can be it is the set of instructions which can be defined by the user, so that according to the user function, user specifications, these devices are going to accept some set of instruction, and generally call them, we can call it as a program, so that according to the user program, these programmable logic devices are going to make the function, and this is the classification of that particular PLDs. So just now I have explained programmable logic devices. In short, we can call them as PLDs. The main objective of this lesson, in this lesson we are going to study some of the programmable logic devices, which includes the PROM, stands for programmable read-only memory, PAL, programmable array logic. Next one is PLA, programmable logic array, complex programmable logic devices, and the next one is FPGA, that is a field programmable gate array, etc. So in this class, I am going to explain how to implement some digital circuit or the Boolean functions using the PLAs and PALs. After the study of the implementation of some Boolean functions using these both PLA and PALs, we have to study the FPGA and the CPLD. FPGA stands for field programmable gate array, and the CPLD stands for complex programmable gate array. From these 5 topics, one question will be asked in the exam. What are the 5 topics we have to discuss? One is PROM, programmable read-only memory, PAL, programmable array logic, PLA, programmable logic array, and CPLD, complex programmable logic devices, FPGA, that is field programmable gate array. From these 5 topics, we can expect the one long answer question in the external examination. So that everyone, please give some additional interest to understand all those things. So introduction, these programmable logic devices, nothing but these are the ICs actually. IC stands for integrated circuit. So integrated circuit can be programmed by making use of the some set of instructions that can be programmed according to the program, user program, that integrated circuits can make the function so that they can be programmed and they can perform the function according to the program, and that so that they had the name of the programmable logic device. An IC that contains the large number of gates, flip-flops, etc., that can be configured by the user to perform the different functions is called as the programmable logic device. So that the programmable logic device contains the logic gates. We know the logic gates, primary gates, basic gates, and the universal gates and XOR gates. All those we can have in the programmable logic devices, and we can have flip-flops, we can have the counters, registers, everything we can find on the PLD, that is programmable logic devices. So that every digital blocks are there in the programmable logic device, so that can be ready to execute or that can be ready to perform the different function according to the user program. So the internal logic gates are the internal logic gates are connections of the PLD. PLD can be changed or configured by a programming process. That means what? So internal, for example, I wanted to implement a function in which the first I require to have the AND gate followed by the OR gate. So I'm having what? I'm having the 2 product terms, and finally I have to add them. That is what it is, a sum of product. So that means what? First I need to write the program for the AND function for the 2 AND gates, and after that I have to add the both of them, so that I have to use the OR function. That means what? Internal connections between the logic gates can be changed or configured by the programming process. That's why we can call it is programmable logic devices. One of the simplest programming technology is to use fuses. That means what? Internally between the AND gate, between the AND array to OR array, AND array to OR array, there is a connection that is called as fuses. There will be the connection through the fuses. We can program these fuses. If this fuse is programmed to 1, that means there is a connection. If this fuse is programmed to 0, there will not be a connection. So that one of the simplest programming technology is to use the fuses. This PLDs has been using the fuses such that if you program such that fuse is 1, such that it can connect the two different modules. And if you program to have the fuse is set to a reset, so that it is programmed to the 0, so that there will not be having any connection between the two different modules. That may be AND to OR to AND, that may be some combinational circuit to the sequential circuit, or the sequential circuit to the combinational circuit. So likewise, if you wanted to have the connection, we have to program the fuse accordingly. That means what? Fuse has to be programmed as 1. So now, in the original state of the device, all the fuses are intact. Intact means there will not be any connection. That means what? These, we can say that that fuse is open or the fuse is intact. Fuse is open or it is intact. So now the programming the devices involves the blowing those fuses along with the paths that must be removed in order to obtain the particular configuration of the desired logic function. Then this is the best block diagram of the PLD. PLD is nothing but what? It is a programmable logic devices in which we can have some AND array or array. Array is nothing but group of similar things, we can call them as array. Group of similar things we can call them as array, so that we have that what? We have the AND array and we have the OR array. That means what? In AND array we can find some numerous, we can find the very huge number of AND gates. In OR array we can find the very huge number of OR gates, so that based on our requirement, some of the AND gates will be selected, some of the OR gates will be fused, so that both will be having the connection based on your function which has to be implemented by the PLD. So that this is the block diagram of the PLD. PLDs are typically built with the AND array. AND array, that is nothing but group of AND gates. OR array, group of OR gates. Now we are having, this is the block diagram. Advantages, just now we discussed all these points. Nothing but it is easy to design and it is easy to implement any Boolean functions, and the space of that circuit is very small because we have been getting the PLDs in the form of ICs. So everything we can have. Problems of using a standard ICs. So before we have the PLDs, we had the standard ICs that can't program. Once it is designed, it will specifically provide one particular function. Some that can be, sometimes we can call them as ASIC, that is application specific integrated circuit, that can't be programmed. That means what? So these are the standard ICs. The problem of using the standard ICs in the logic design, that can require the hundreds and thousands of ICs, considerable amount of the circuit board space, a great deal of time and cost in inserting the soldering and testing everything. So advantages of PLDs, we have what? Problem advantages. The advantages of using the PLDs are less board space, faster, lower power consumption, because all these are available in the small integrated circuit, less costly assembly processes, higher reliability. Everything we have advantages from the PLDs. So now we can have this one is, now see this one, these are the PLDs we have. One is PROM, stands for Programmable Read Only Memory.
PAL stands for Programmable Array Logic, and the next one is PLA, Programmable Logic Array, and all these comes under what? These are the simple PLDs. Simple PLDs, in short we can call SPLD. And the fourth one we know that just now we have explained, that is the complex programmable logic device, and the next one is about the field programmable logic device. Anyway, these two will have some millions of logic gates inbuilt in that particular board. So FPGA has been using in the VLSI circuits lab, or some electronic circuits lab. So that can be programmed according to the user program, that can be used to provide the function according to the user program which is dumped in the FPGA kit. Then we will be going with some other. See this one. This is the conventional AND gate. This is the conventional AND gate. This is the conventional OR gate. But here this is the array logic symbol is nothing but this cross symbol is nothing but these can be programmed. This can be programmed. For example, if I require this input, so that accordingly this input will be programmed so that it will be connected as an input for the AND gate. If I don't require this one, if I don't require the second input, such that it will be programmed in such a way that it is not going to give any input to the AND gate. So but in case of a conventional one means what? Irrespective of that input signal, every time we require to apply the input signals so that it will give that particular output. But here, for example, here this is having what? 3 inputs. Assume that 3 inputs it is having, so that it will verify for all the 3 combinations, that is 2 power of 3 combinations means what? 8 combinations it verifies. Zeros, 000 to 111. But I require to have only 101, so that I can program this is 1, I can program this is 0, I can program this is 1. So that this that will provide the operation very fastly. This is about the fundamental difference between the conventional AND gate and the array logic AND gate and OR gate. These are the fundamental 3 fundamental types of PLDs are there. First one is what? First one is programmable read-only memory. Programmable read-only memory. We will be using the just now I have explained in the programmable read-only memory. We can make use the decoder followed by the OR gates. Decoder is a combinational circuit which is going to retrieve the original information from the coded one. So from that we can have the fixed AND array, so that if you take the output of the decoder, it is nothing but it is AND gate only, so that we will be having some array of fixed AND gates. Now that will be connected to the programmable OR gate. This can be programmed according to user program. These can make the connections through the fuses. Coming to the next one is about here. This can be interchanged now. In case of programmable array logic, AND plane is programmable, OR plane is fixed. In case of PLA, and both will be programmable. This is programmable and this is programmable. So that in this 3, that PLA offers the more flexibility to the designer, and in which we can find the AND array is programmable and OR array is also programmable. AND array is programmable and OR array is also programmable. I am going to conclude this session. See this one. In case of PROM, and AND array is fixed, whereas OR array is programmable. Coming to the PAL, in which the AND is programmable, OR is a fixed one. In case of PLA, both will be programmable, such that you can remember this one. So whatever I have explained, this is programmable. Just now I explained all these things, so that this is about a PROM. PROM, this is what it is having, what? The decoder followed by the OR plane. Decoder followed by the OR plane. OR plane is programmable. Each output of the decoder is a AND gate only, so that AND gate generates the one of the possible product, that is about the AND is nothing but it is used to provide the min terms. So all these things we have studied, all those things we have studied. This is what it is about the, it is a PLA. PAL is what? It is a programmable AND gate and the fixed OR gate. If you go with the PLA, both are programmable. Now this is programmable and this is also programmable. In such a way, we have to remember the PAL and PAL. This is about the thing, everything. Now we have to go with the one of the example. Before going to discuss the example, I must explain the one of the important classification of the programmable logic device. See this one. This is the comparison. So see, FPGA stands for what? It is what we can call it is simple programmable logic devices, in which we can have the PROM, PAL, PLA, and these are comes under a FPGA, simple programmable. Next one is what? CPLD, complex programmable logic device. FPGA, we can have the around the field programmable gate. So now it is a comparison. It is a comparison between these two. Density of the logic gates. Density of the logic gates are very low. Few hundreds of gates will be available. But here density is it is offering the medium one, and we can have the 500 to 12,000 logic gates in the CPL. Whereas in the FPGA, more than 50 lakhs of logic gates can be available on the FPGA. As usual, FPGA we can get in the low cost, and we can get this is in the medium cost, and this is we can get in the medium to high cost. So major vendors, all these we can have CPLD, we can have the Xilinx, Ultra. In the labs, in the VLSI lab, those who belongings to the electronics, they will they may know this one. Xilinx we will be using the software and the hardware, and like this you can have the comparison between these. Next one is what? History of the programmable logic devices. Just now I have explained. So programmable techniques also I have explained. Some memory devices we have studied in the first part, that is programmable read-only memory, and in which we can have the erasable programmable read-only memory. After that we have studied the electrically erasable programmable read-only memory. Then UV EPROM, that is also we have studied ultraviolet erasable programmable read-only. So all these things we have studied. Then programmable technology also we have studied. Then I am going with the next slide. This is about the ISP, and we can have this all these programmable logic devices in the form of an integrated circuit, such that we can have this one in the case of VLSI circuits. Now I will be going with some of the examples, such that everything will be clear now. So now I am going with an 8-bit. This is about, assume that it is the ROM, so that it is having the 3 inputs, so that it can have ROM. 3 inputs means what? We can give the 2 power of 3 combination. That means what? We can have it is we can have that is 000 to 111, 00 to 0. So typical data is stored in the output lines. That is we can have this one. See this one. We can have the typical data stored in a ROM 2 power of 3 word of 4 each bit. That means what? The size of this ROM is each line. It is each address, each memory location in the ROM is used to store the 4 bit of data, so that based on our program it is used to some, it is tentatively taken, so that is not having any particular sequence to follow that one. So this is what? For a 000 it is storing the 1010. If I give the 001 and it is storing the some other information, that is it is remains a 1010. Like that it is having some storing the information. So that read-only memory with n inputs and m output. N inputs nothing but the input address lines, whereas m is nothing but for each location. In the each location some m number of bits has been storing in that. See this one. So here it is having what? How many inputs it is having? Inputs, n inputs having, so that it can have the 2 power of n number of combination. 2 power of n combination, all zeros to all ones. So for all zeros it stores 1 bit. That in m bits it requires to have what? M bits. Each location is capable of storing the m bit. Anyway, all these things we have discussed. Next one, we are going with the block diagram and truth table of 2-bit adder. This is very simple to implement. See this one, 2-bit adder. That means what? X is a 2-bit 1 and Y is also 2-bit. X is a 2-bit binary 1 and Y is also 2-bit binary. And anyway, from the output of any adder, we can have the 3 combinations only. We can have the 3 combinations. That is about the sum and carry and some. If you go with the comparator, we can have the third one, that is what? A greater than B, A less than B, and A is equals to B. But in the case of adder, we can have the only sum. So now I am going with the combination is what? See this one, X. Now X is a binary number in which we can have the 2 bits. Y is also binary number, it can have the 2 more bits. So that is A is X is 0 0, Y is 0 0 2, X is 1 1, Y is 1 1. So that we can have total 4 bits, right? So that we can have the 16 combination. 2 power of 4 is equal to 16. 0 plus 0 plus 0 plus 0, 0 only. 0 plus 0 plus 0 plus 1, 1 only. Like that, if you take this one, what? 1 plus 1 is 1 0. 1 plus 1. 1 plus 1 is 1 0 plus 1. So likewise, we can have the sum, so that we can have, see this one. Here we are having like that. We can have the everything, so that we can go for. That means what here? 0 0 plus 0 0, 0 0 plus 0 0. Obviously 0 0 we will get. And coming to here, see this one, 0 0 plus 1 0, so that we can get 1 0. 0 0 plus 1 1, we can get 1 1. Then now go with this combination, 0 1 plus 0 1. 1 plus 1 is 1 0. We are getting like this. So this is the implementation of the 2-bit adder. Now see this one, x1 x0 y1 y0, and we can have the four inputs are there, so that we have to select what? We have to select the encoder that is about. We have to take the encoder or the RAM size. If this is having the 4 inputs, so that RAM is nothing but it will follow by a decoder 4 to 16, so that 16 outputs will be having. That is from we can have the D0, we can have the Y0 to Y15. From that we will be taking only 3. What are those? S2, S1, S0. Like that we can implement the any combinational circuit by making use of the RAM, PROM. So now this is the RAM truth table and this programmable array logic. Now the programmable array logic, just now we explained, that is what? In the programmable logic array, both the AND gate and both the OR gates are programmable. Programmable array logic in which the AND gate is programmable and OR gate is a fixed one. So here we are going with the programmable logic array, and just now I have explained, this is AND array and this is OR array. Array is nothing but group of similar things are called as array, and here this is what? It is a programmable one, and here also programmable one. So now both the AND gate and both the AND plane and OR plane are the programmable. So now you can see this one on OR functions. Actually these things are not needed for the this much, not needed. This is also not needed. So this one is PLA a representation of the previous circuit. See this one. So we have, for example, we wanted to implement F1, F2, F3. What is the F1? F1 is equals to, see this one, F1 is equals to A bar D plus ABD plus ABC, A B bar C bar plus B bar C only. Only 4 terms we will get at F1. F2 we will get only 3 terms. What are those? A bar BD, B bar C, BC. In F3 we will get the 3 more times. Like that, based on the question only it is going to, this is, see this one. F0 this is. See this one. F1 is what? F0 is 2. That is what? A bar B bar plus A C bar. Next F1 is also 2. F2 is 3, 2. F3 like that it is having, and like that you have to go with the F1, F2, F3. See this one, F1, F2, F3 we have to go, and it is having the F0 also, but F0 we didn't mention. So we know this K-map, and after getting the F1, F2, F3, we have to implement that is with the PLDs, that is F1, F2, F3. Sequential circuit also can be implemented. Next one is about programmable array logic. In the programmable array logic, we know that AND gate is a fixed one, AND gate is programmable and OR gate is fixed. This OR gate is fixed and AND gate is programmable. Like that, we can go for the PAL. So that this is the best example for the PAL. PAL stands for programmable array logic. See this one, full adder. Implementing the full adder by making use of PAL. Full adder is a combinational circuit which is used to add the 3-bit binary numbers at a time. So that means what? That means output of the full adder will be the two lines. One is sum and another one is a product of sum. Another one is a carry. So this is about sum and this is carry. Wherever the product term is needed, that will be only programmed. This cross indicates it is programmed. Programmed according to the program. This AND is giving the output and such that is connected to the fixed OR gate. This is about the PAL, programmable array logic, and it is interconnections between all these things. Now sequential PAL also we can implement. This is the sequential PAL. So now this is what PLD basic structure, programmable array logic structure, in which we have the AND plane. AND plane is with the programmable, OR plane is programmable. See this one, this is OR, it is fixed, and all these are programmable. Here we need the connection, so that we have used these only, remaining we left. So wherever we require the connection, that can be programmed so that can be accessed the input. Particular AND gate will provide the output, and that will be acting as the input for the OR gate. From that we will be going with the flip-flops and some lookup table, such that we will get the output. So that these are the devices which make the function according to the user program. So I am going to explain some CPLD and Fpga also. So now I'll go with the another slide. See this one. Implement the combinational circuit using the PLA. PLA nothing but what? AND is programmable, OR is fixed one. So the first one we have to F1. We have to get the function for F1. We have to get the function for F2 by making use of the K-map. Now F1 is what? F1 is about the AB plus AC plus BC. F2 is equals to A bar C plus A bar BC plus ABC. That we have to implement. See this one? F1 is this one, F2 is this one. So now you can directly, next one is PAL. PAL means what? It is about the AND gate and OR gate. Both of AND gate is programmable, OR gate is fixed one. See this one, this is the same notation. Cross mark indicate it is a program. So like this we can make use of PAL. See this one, this is the PAL representation. So anyway, I'll share all these things with you, such that you can go with the everything. So now we left with the only two topics, that is CPLD and Fpga. In the tomorrow's class I am going to explain the Fpga and CPLD. Thank you, students.